by b, a to the power 3 by b plus a by b to the power of 3. Now here, just talk about the two instances of when we multiply. Here, if we multiply AB times AA, we multiply AB by AA. Once we multiply that, you see AA is also equal to A squared. So that's AB times A squared. So we have AB times A squared. Now, here, you're just going to multiply A by A. You just ignore you don't have to multiply by the B. It's already attached. So, here the A is understood to have a 1. So you add so you simply add the exponents. So this form also is equal to AB times A squared is equal to A to the power of 1 plus 2 by B is equal to A cubed by B. You see, that's how we got this. This is applying the law I just showed you. This is basically the most basic form you can find it. But if you get to if you get to instances where you have more variables, you're going to have to use the law. Now, to show you how we got this number, apply AB, multiply that by BB, and that's going to give you this. So to show you, but BB is B squared. BB is B squared. Now that equals A times B to the power of 1 plus 2, which equals A B to the power of 3. Let's say if we have some numbers now. Let's say we have 2 plus x. 2 plus x is simplified. Cannot add to an x because they are unlike terms. But why are they unlike terms? They're unlike terms because here, because x it has no variable. 2 has no variable. If it did, we would say x to the power of 0, which is 1. But also, but if you notice, the degrees are different. I'm going to give you the law now for when an exponent, for when terms are like or unlike. So 2 terms are alike when all the variables are the same. And each variable is raised to the same power or degree. So if they don't meet these conditions, they are unlike. This means that x can be added to 2x to give us 3x. Okay? We can add like terms. We cannot add unlike terms. So here, these two terms are like because they have the same variable, and each variable is raised to the same power. Remember, x equals x to the power of 1. So here in both instances, x is raised to the power of 1. See? It's like if I had x squared plus 2x squared. That's going to give me 3x squared. Now, but I wouldn't add x to x squared. That's simplified because that breaks down into x plus x by x. See? Because if x equals a certain number, let's say x equals 3, we will have 3 plus 3 squared. So that gives you 3 plus 3 times 3, which is 9. You see, but if I did that on the left side first, how would you know how to deal with that? That shows you they have two different values. They are not like. So here I know it's 9 because I know what numbers we're dealing with, but here you wouldn't know that. We're dealing with the variables. What I mean to say is, what am I going to write here? We know this equals 12. But what symbol am I going to write here to represent the final sum? I have to write what I wrote. X plus x by x, because that's what this is. 3 plus 3 by 3. 9 is 3 by 3. You know, it's two different numbers. 3 and 9 are two different numbers. Just like x and x squared are different terms. You cannot add them. Now don't get confused, we just multiplied. Remember, we multiplying numbers when multiplying numbers with different bases. We add the exponents. So you can, remember, you can multiply unlike terms. You can always multiply terms that are unlike. You just can't add them. In your books or in your studies, they call them combined. They call them combined when they mean add. But I specifically say add. You cannot add like terms. You can multiply them, but you would not add them. See, that's different. You don't add them, but you can multiply them. I'm going to show you some examples like terms. Now let's say we have x xy plus xy. It's going to give you 2xy. It's going to give you 2xy. xy